How do electron configurations correspond to the periodic table? Me personally, I really like this question because, as you can see here, the way the electrons are configured is because, well, not because, they like to go in pairs. So there are 4 types of shells you know about. There are S, P, D, and F. Okay, these are just the shell names, but this also kind of explains in terms of like the specific type of orientation the electron has. So S comes with 1, okay, and I'll explain what each box does. But P has, according to this, just to make sure I have it correctly, 3. 1, 2, 3, 4, 5. Yep. And then D has around, like, you can go up to 2, 3, 4, 5, 6, 7, 8. I believe it has 5. And F, that's the one that goes up to 7, I believe. Okay. And now in each box, 2 electrons can fit in. Okay, 1 electron will be rotating upwards and the other one will be rotating downwards. Just going to draw that a little better, and that applies to every box. I would love to draw it for each one, but it'll get kind of tedious. But that's the idea around it. So pretty much the maximum S can have will be 2, P will be 6, D will be 10, and F will be 14. Now, how does that apply to specifically getting to the periodic table? So the S's, these 2, are specifically for the first row, okay, the alkali metals. So hydrogen, lithium, sodium, potassium, and it keeps going on. That is the first row of S. Now you're probably thinking that the second row of S would actually be the next one, the beryllium, but funny enough, it's actually going to be the noble gases, funny enough, because think of it this way. So hydrogen is the first element, okay, so it has, like, you know, the nucleus and 1 electron. That's hydrogen, okay. The way you notate this is 1s1, because this is the first row, and then S because it's a shell, and 1 because that's how many electrons are in there, hence the space it can fill. Now, instead of you skipping down to beryllium, you actually go to the next element. The next element, okay, so this is hydrogen. In fact, I'll make this a different color to keep track. The next element is helium, and that's actually the one that we refer to. In fact, let me just draw it like this. It's an electron, okay, nucleus right there, and 2 electrons on this shell, and this one's actually called 1s2, okay. That is for the S row specifically. Now P is what I kind of call, it's kind of like a giant sandwich, okay. The way I picture it, it kind of goes like, yeah, drawing a sandwich actually. S, and then P, and then D, and then F. The reason why I say it's kind of like a sandwich, specifically for the periodic table, is because the P's actually start at beryllium. So that row right here, okay, if you can see, will like beryllium, and it will stop at fluorine, okay. So for example, if you were to write down the electronic configuration notation for fluorine, usually what they do is that to indicate that that row is done, they just put it in brackets. So helium, for example, is finished because you have to go through the whole helium to get to fluorine. And so you skip over hydrogen, you skip over helium. That's what this covers, okay. And it would actually be 1s1 and actually not 1. Whoops, sorry. It'll be 2 because now the second row, S1 and 2 P5. Now, funny enough, that's actually not what fluorine prefers because it's actually easier and more stable for it. It likes to keep at least one shell. For most things, like to keep at least one shell just full if it can. So actually, you can just actually write this as 2p6. That's a more stable form for fluorine. So forego that helium. It's still missing the 2s2 though. So that's what it would do there. Actually, let me just double check here. No, whoops, sorry. Miscounted. It actually is already full. So this would be fluorine. If it was oxygen, that's what would happen there. But I miscounted there, so just to make sure, beryllium is 1, boron is 2, carbon is 3, nitrogen is 4, oxygen is 5, fluorine is 6. So this right here will be electron configuration for fluorine. That's how you'd write it. What this I'm trying to say is that is a p row. Now, D, if you're kind of going with the sandwich thinking, if you see here, right, it says all transition metals, right? So that would be where the D shells go. So that's why in terms of configuration, it does get more and more complicated. But the one thing to remember is that for D row specifically, whatever shell you're on, so let's say the shell is N, okay? For D, it's N minus 1. So as an example, let's pick scandium. Actually, let's pick something that we know. Let's pick iron. Might be a little tricky in terms of, just balancing it out, but the concept is that, so we first start with argon, okay, and it's gonna have the row is 4 now, so 4s1, and it's going to be 1, 2, 3, 4, 5, 6. So 3d6. And what actually this prefers is that because this is the lower number, technically the way to write it, you always want to start with the lowest number first. So the proper way would be argon 3d6 4s1. And the reason why it's 3 is because remember for the P rows, for the D rows, you want to subtract by 1. So that's what the D shell refers to there. And now for the last one, the F shells, okay? The F shells, so exactly same concept for F. It's going to be N minus 2, okay? So, and that's all the lanthanum and actinium elements. So let's pick something that, well, I'm not familiar with any of this, but let's pick uranium, okay? Uranium is a pretty relatively safe bet because we've all heard of that that element, hopefully. So uranium, we kind of just can skip because it's on the 7th row. So radon from the 6th row would do just fine, okay? And we know that it's covered 7, so that's 7s1 that's covered. We'll reorganize it later. And the F starts first because it goes straight into it. Uranium is the 3rd one, so it's going to have 1d because if you remember the actinium and lanthanum series still counts as the transition metal, like in the D row, not the F row yet. So everything after is the F row, okay? So it's 1d, so that's subtract by 1, 6d1, and then 1, 2, 3, and 1, 2, 3, that's 5f3. There's probably a much nicer way to write this. 6d1, whoops, 7s1, and that's just an example. In terms of what they actually prefer, that one gets a little bit more complicated, but this would be kind of the concept for this. Now, how does it all tie back together? When I refer to the shells I like to occupy, if you notice, it actually coincides exactly with the amount of rows they are. So S, for example, remember in the sandwich, hydrogen row, helium row, 2 rows only, which is why it's only up to 2, and it's technically just 1, but that's why it's up to 2, because every electron has to be paired, usually just like the shell configuration. Now then, P's, because you notice how we have 3 boxes, which means 6 electrons. If you count, beryllium is 1, boron 2, carbon 3, nitrogen 4, oxygen 5, fluorine 6. That's how we got 6. D, 10, okay? And you notice that there's actually 5 of them from scandium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hence why we have 5 boxes here. And if you guessed it, the lanthanum and actinium series, starting after lanthanum, there should be 14 of them. So from cerium to lutetium, it should be 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that is how all of that, in a sense, corresponds to the periodic table. It's quite a long explanation, but this is pretty much a breakdown of it. This picture here specifically shows how the electrons like to fall in line. So if you notice that once you get to the 5s series, so the 5th row of the periodic table, that's the last part, because once you hit the 6th row, you start dealing with the F's, and once you delve into once you deal after the 6th row, that's when you start dealing with the F's, and then the 7th row is the last F. But it's kind of how the breakdown of it. And yeah, let me just see what they say about that. Yep, they talk about each alkali metal ending with S1, and just depending on the row they are, that's how they correspond. Okay, and in group 2 elements, the alkaline earth metals all end in S2. So that one, that part is not correct, because as we discussed, those are more of the halogens that end up in S2, because the alkaline earth metals, that's when they go into the P. So, because they're thinking it more like it's kind of just linear, but think of it more of a sandwich, especially with the periodic table. It's more of a sandwich, okay? Transition metals, exactly, do talk about that. Groups 3 to 12, that one is where we've hit the D shells. And then they talk about the rare earth metals, the lanthanide and actinide series. That's where we hit the F shells, okay? So let's review this actually, just to see. 1s1, 1s1, 2s2. Interesting. Okay, I see what they're saying now. That makes okay. All right. So based on this explanation, if we're going by this is what the textbook says, then in this case, because I want to make sure that the right information is being passed down. So for fluorine, for example, if we were to revise it, it'd be 2s2 2p5. In fact, I'll write it in red so we can keep track. 2p5, okay? And that would be the configuration. Argon would be 4s2 3d. Well, yeah, 4s2. And where is Argon here? We agreed that it was right. Nope. Oh, that's why, 'cause I was doing an iron. There we go. So iron, yep, 4s2 3d 1 2 5. Okay, 2 3 4 5. Oh, it's still 3d6 actually. Okay, and then you want to rewrite it, so it'll be 3d6 4s5. That makes more sense. Okay, so this is good that we're able to catch that. So this is indeed correct. So specifically on the periodic table, the only element that counts as 1s2, but is on the other side, will be helium. So if you were to redraw the periodic table to weigh that the helium is not with the rest of noble gases, the table will look kind of like this. So in terms of rough draft, okay, this would be the S series, okay, and then this would be the D series, this would be the P, and then this little bracket here will be the F. So sorry about that, and I'm glad we clarified. So it almost still works as a sandwich, but that only applies for the D and F series. You'll find the F series only in places that have the D series, and you only find the D series between the P and the S. So to emphasize once again, once you hit the alkaline earth metals as they stated, you're still in S2. So to avoid complete confusion, all right, if we pick magnesium, magnesium would simply be neon as a start, okay, and then it'll be 3s2. This right here is magnesium. So apologies for the first statement, okay. And if you want to pick, for example, sulfur, okay, still neon, and then we go 3s2 because it's in the third row, and then you count 1, 2, 3, 4, and there'll be 3p4. Okay, so sorry about that, because I want to make sure that this concept is thoroughly understood and we don't want any confusion. So they are correct. So if you made it this far, just make sure that you treat it like a sandwich, but only for the D and F rows. S and P